Okay, now we come to the third topic, which is on amplifier characteristic. And you should know that amplifier is actually an electronic device or circuit where we use it to increase the magnitude of the signal. Okay, so we want to amplify the signal. It could be the voltage, it could be the current. Okay, then meaning when one signal it goes through at the input terminal here. Okay, if the input is being connected at the input terminal here, one signal, it goes through the amplifier, then as you can see at the output it becomes larger. Because why? It is being amplified now. Okay, so when we talk about amplifier characteristics, you just imagine the amplifier just as a simple box. Okay, you don't know what's inside. Okay, because it can be made of many transistors, BJT or FET. As the amplifier at the moment you don't have to know, but you just imagine as having one simple box here, a black box. Okay, then at the input terminal it is being connected to the input signal, at the output terminal it is being connected to the output signal. Okay, then all you have to know is this amplifier should have three main properties. What are they? It should be having R in, and it should be having R out, it should be having the gain. Okay, so all these three you have to know in order for you to represent the amplifier characteristics accordingly. Okay, so what are the three main properties? Input resistance R in, output resistance R out, as well as the gain. Okay, talking about amplifier characteristics, actually there are four models that we can consider. The first one is voltage amplifier. Okay, then later we are going to discuss about current amplifier, transresistance amplifier, as well as transconductance amplifier. But let's start with the voltage amplifier. So as the name it is, we know this amplifier is being used to amplify the voltage, obviously, right? So the gain of this voltage amplifier, normally it deals with the output voltage over the input voltage. What will be the unit? There is no unit because the gain is just the ratio between output voltage and the input voltage. Okay, so in this case, if you are having AB equals 10, what does it mean? It means that the signal is being amplified by how much? By 10 times. Okay, so for example, if you are having input signal like this, okay, the amplitude, then after it goes through this voltage amplifier, because the voltage gain is 10 just now, so it becomes something like this, right? It becomes bigger. Then how do we represent this voltage amplifier? Remember I mentioned about the three main properties just now, so you should represent the three properties, the Ri or R in, R not, and AV properly. So in this case, for the equivalent circuit of this voltage amplifier, you can see here Ri is here, and we have the AVVI. Okay, open circuit voltage gain. AV is the voltage gain, VI is the input voltage, this is VI, remember? Okay, then R not output resistance is in series with the AVVI. Okay, so what you should take note is we have Ri here, we have AVVI here, and in series to it we have R naught. This is the equivalent circuit of a voltage amplifier. Here is one simple example on voltage amplifier. So it's given that output voltage is 10.5, input voltage is 150 millivolt. So straight away you can get the voltage gain by getting the ratio of these two, 10.5 over 0.15. So you are going to get AV equals 70. What does it mean? It means that the signal is being amplified by 70 times. Here is another example related to voltage amplifier. So as you can see here, this is voltage amplifier equivalent circuit where it has Ri, it has AVVI, and in series to it, it has R naught. In this case, for this particular example, it is now connected to one load resistor RL. Equals to 475 ohm. Okay, then it mentions that the output voltage across the load resistance is 10.5. okay, then it also mentions that the VI is 150 millivolt, okay, as well as the output resistance is given as 25 ohm. Okay, what you have to find, you have to determine the open circuit voltage gain AV. Where is this AV? This is the one. You see here, this AV, this is called open circuit voltage gain, AV. Okay, so how are you going to start with this analysis for this particular amplifier? So as you can see here, for this, this is one closed loop, right? One closed loop. Then for this particular path, you can see that voltage is given, the resistance value is given. So from here, straight away, actually, you can find the current. Okay, remember the Ohm's law. Okay, so from there you can straight away calculate for the output current, which is 10.5 divided by 475 ohm. So you straight away get the output current. Okay, please take note that this loop, when I mention one closed loop here, this loop actually is related to the output loop. Okay, and this loop actually is related to the input loop, but in this case the input is open, right? So there is no closed loop here, there is no I mean it's open loop, and obviously there is no current, there is no input current because the loop is open. But in this case, at the output side, we have the output loop, a closed loop, right? So from here you can get current, and is this just one closed loop? So as obviously it's just the same current, right? So what you can do next, you already found for the I0, then for this one closed loop, actually you can do KVL. Okay, so remember AVVI is just voltage source, right? Because AV is the gain, no unit, times the VI is the voltage. Okay, so actually from this you can get one KVL equation, which is minus AVVI, right, plus I0 R0, the voltage drop here, okay, plus V0 equals 0, right? You do KVL, so from here actually you can get AVVI, okay, equals I0 R0 plus V0. Okay, so I0 you already calculated just now, 22.1, then R0 is already given 25 ohm, then V0 is also given 10.5. so from here you can solve for it, then you are going to get 11.05 volt. Okay, and in this case the question is asking for the open circuit voltage gain AV. The one that you are calculating just now is AVVI. Okay, so in this case you can find AV simply by divide the answer with the VI value, so you are getting AV equals 73.67. Okay, another example related to voltage amplifier. The difference now is, as you can see here, at the input side also we have one closed loop, right, and the output side also we have another closed loop. Okay, so we are having two closed loops here, right? And what is the question? The question is asking us to determine the output voltage across the speaker. So as you can see here, the big picture of it is actually this voltage amplifier now is connected to a microphone. Okay, so the signal coming from microphone, it goes through the source resistance, then it enters the amplifier model. Remember the black box? Okay, then after it goes through the amplifier model, the output signal now is being connected to the load resistor, where across this load resistor is the loudspeaker that we are going to amplify the voltage signal. Okay, that's the application of it. So in this case you have to determine the output voltage across the speaker, which is what should be the V0 here. The question is asking us to find for the V0. Okay, that's the thing. All the other parameters are given. So basically what you have to do is, in order for you to solve for this closed loop, because you want to find for the V0, right, the other parameters are given, but you don't know the VI value. Okay, so Vi is unknown. So what you have to do is you have to start with this loop first, the input loop. Why? Because here we know the Vi. So how do we calculate for this Vi? Number one, we must calculate Vi. How? As you can see here, we have Vs, we have Rs, we have Ri. Here we need to calculate for Vi. In this case, what can you do? You can use voltage divider. Okay, so you can use the voltage divider. Okay, so you calculate for the Vi, or you can still consider the Ohm's law. Okay, because you know the Vs, you know the resistor in series here, right? So you can find the current. Okay, so once you find the current, you can calculate for this Vi, which is the current times the Ri. You can still get the Vi. So there are two ways: either you do the voltage divider or you do the Ohm's law. Okay, Vi is Ii times Ri. Okay, you can use any methods here. Okay, so once you find for the Vi value, remember in this case AV is given 100, so then you can find for AVVI here. Okay, then what you have to do next is you want to find for the V0, right? So in this case you can do the same thing like you do in the input loop, where you can do voltage divider, okay, to find for the V0 now. Okay, because why? AVVI, you know, the R not given, RL also given. From here you can find for V0 using voltage divider, or the same thing you can find V0 by finding the current first, then the V0 is actually I0 times RL. Okay, so from there you can solve this equation. Now we come to the second model, which is the current amplifier. So as the name it is, you know that this amplifier is amplifying current, obviously. So the gain is related to output current and input current. AI equals I0 over II. It gives us the ratio of the currents. Okay, take note, the gain always no unit, because it's just the ratio. But what I want to highlight here, for the current amplifier, the equivalent circuit is a little bit different from the voltage amplifier. We still have all the three main properties, remember, Ri, the gain, as well as the R0. But now in this case, R0 is in parallel to the gain. Remember just now for the voltage amplifier, R0 is in series, but in current amplifier, R0 is in parallel to AIII. This is the current gain. Okay, so we still have the three main properties, Ri, AIII, and R0, but in this case, R0 is in parallel. Here is one simple example related to current amplifier. In this case, you need to find for the output short circuit current is given. Okay, then the current gain is given as -50. So now you have to determine the input current. Okay, so it's very straightforward, right? I not given, AI given, so all you have to do is to find for the II, right? Okay, so if you plug all the values, you are going to get the II. Okay, here is another example. The short circuit current gain, which is AI, is given as 30 and output resistance is 2.5 kilo ohm. We have to determine the output voltage, which is V0, the voltage across the load resistor here, when its output is connected to a load resistance of 450 ohm, which is this one. II is 0.5 milliampere. This is II. So in this case, we have to find for the V0. So in order for us to find for the V0, because RL is given, it means that we have to find for I0, which is the output current. So in this case, II is given, remember. So what you can do is first calculate the value of AIII, this one. Okay, AI given, II given, you can find this value, right? Then using current divider, you can calculate for I0. Okay, use current divider to calculate for I naught. Then once you find for I naught, remember you can just use Ohm's law to find for output voltage, because V naught is given by I naught times RL. Then for the third part, we have transconductance amplifier, which is actually it amplifies the transconductance value. I don't want to go into details for this as amplifier model, because our main concern is on the voltage amplifier and current amplifier. So it's enough for you to know another model is transconductance amplifier. Then the last one is trans-resistance amplifier. The same thing, you don't have to know into detail. It's good to know that there are four models: voltage amplifier and current amplifier, where you need to know in details. But for transconductance and trans-resistance, you just need to know it's one of the models available in electronics. Another thing in electronics which is quite important for you to know is whenever we are considering signal source or signal generator, okay, so if you want to model a signal source which is the voltage source, it's normally modeled with Vs, and the source resistance is in series to it, Vs, and Rs in series to it. Okay, but if you want to model the current source, okay, the Is, the current source, we have source resistance in parallel to it. So as you can see here, Rs is in parallel to Is, while for Vs, Rs is in series. Okay, now we come to the last part of this chapter 1, introduction to electronics. But for this part, for the examples, I don't want to discuss here in the lecture video. These examples I'm going to discuss with you guys during our synchronous lecture. Okay, so that's all about chapter 1 that you need to know. Assalamualaikum.